I'm Alex Bailon, working for BayLibre, and today I'm going to talk about using Zephyr for building home automation devices. So the home automation is provides some convenient things for the home, for automating the home. So basically, you could have some fancy things such as switching on a light using a voice assistant, or more useful things such as controlling the heater to make sure you still have the comfortable temperature in your room. And you may consider also some use case such as going in vacation. The home automation will lower the temperature automatically, and when you come back to home using the GPS on your smartphone as example, detecting that you are going back and increasing the temperature of the heater, so you come back to home and you have a good temperature and it's comfortable. There is a lot of company doing home automation devices. So you have the voice assistants that are quite common. So you can find some sensors, a lot of things. The main issue with existing devices are every vendor is doing some solutions. There is a lot of protocols, a lot of different solutions. There is some vendors that are trying to leverage it by using the same application, the same protocol. But in most of the case, you need a lot of application on your smartphone to get access to some devices from Samsung, to get access to some devices from, I don't know, Apple, not good example. And another big issue is the privacy. All the devices are using internet and using some external servers. The data are going somewhere, you don't know where, you don't know in which country, under which regulations. So that's a big issue. Another problem is electronic waste. Some of these devices are poorly designed. Not all, but some are poorly designed. So after 1 or 2 years, they fall, they stop to work, and you can't do anything to repair them because you don't have any schematics, any services manual, anything else, any documentation. Another issue is that when the vendor company failed, so they stop the servers and your object doesn't work anymore, whereas the hardware is still working, but you don't have access to the server, so you can't do anything with it. Because you have some dependencies on external servers also, sometimes if you have a poor internet connection, your home automation could just stop to work or work badly in a fallback mode. So all of that is not good user experience, and I got some issue with my home devices. I'm using home automation for heating my. I have a big room, and I use it. I have many sensors, temperature sensors, and I want to be sure that at some place I have a good temperature, not too hot, not too cold. And using my home automation, I make sure that I switch on the heater if I need more temperature, I switch it off, and so on. But I have some sensors, some temperature sensors that often disconnect and never connect to my home automation. Sometimes they just stop to work at all. I can't do anything. I could just trash them. Same for my heaters. I use the AC to heat my room. But sometimes when I lose internet connection, the AC just remains the same state. So sometimes in winter, I have to open the window because the room is too hot because one sensor has just stopped to work, or the AC has lost connection, which is pretty bad. So I end up with starting my own home automation device. So because the one I found in the market are not good enough, I try to do my own. I want to do something that is open hardware, so anyone could have access to schematics, to the PCB, and could repair it itself or improve it. Because I'm not an electronical engineer, so I did the design myself, but I know it's not perfect. So anyone could improve it. I want also to have open source because I want to be able to fix the firmware myself, but anyone else could be able to also to fix it because, again, I could do some mistake. My goal is really to provide something that will give back control to users. I had a look to some existing solutions. There is a popular ESP-OM and Tasmota, which are open source firmware for ESP-based device. But the issue with that is that work with ESP devices. They are trying to add new support for some SoC, but it takes time. It's not made for that, so it's quite complex. I also had a look to some open hardware solutions. The only one I found is mostly made for makers, so it's not something that is ready for a user, I would say, for a consumer market. And there are also some hardware devices also that allow flashing a new devices, new firmware, sorry, or that come with some open source firmware using ESP-OM pre-flashed. But again, this doesn't solve the hardware issue when it stops to work. You don't have any documentation to fix it, so it still remains difficult. So my goal is really to provide everything open source and open hardware, but still to provide to build a consumer-ready product, something that my dad could buy and install itself in the house. So the first product I wanted to do is a power switch or a light switch. You could do both actually. So this kind of hardware is quite simple because you just have a relay to control, and this makes also the software quite simple. The only constraint is about the size of the hardware, because I want to do a module that could be installed in the wall. For the firmware, the requirements are the same as for a real product, I would say. So we need secure boot because we want to make sure that we only flash the firmware we want. That's an issue for maker. I don't know how to address it actually. The OTA, because we want to be able to deploy new features, to get some security fix. Provisioning to add the new device on the network, and some configuration for the user. Basically, something I found quite annoying with some hardware is the status LED. The LEDs that remain on all the night when you try to sleep. So I want to be able to configure this kind of thing. So why using Zephyr? Actually, I use it every day at work. I work a lot with Zephyr. This is an OS that is already suitable for making a product for a market. This is already used in a lot of products. It supports a lot of SoC, not just only the ESP. It has support also for a lot of radio protocol, a lot of connectivity. So it's really awesome for that. So you could easily design a product for home automation with almost everything Zephyr has already support. It also provides a lot of libraries such as JSON, CoAP, and things like that. And it's open source. So I spent a lot of time trying to select a SoC and defining the network requirement, what I want to have. So something important for me was having a dedicated network. Basically, you could use Wi-Fi. A lot of devices actually are using Wi-Fi. But if Wi-Fi fail, all your home automation is failing, is stopping to work. And there is a lot of reason why Wi-Fi could stop to work. So, in my opinion, it's better to have a separate Wi-Fi network. The consumption is quite important because some devices are using a small battery, so it have to last a couple of years. So you have really to be careful with the power management. The mesh networking is a useful feature to extend the range because in the house, depending on the age of the house, how it has been built, you could have a very low range to a big range for the same protocol. So having the mesh networking could help to improve the range without too much effort. Also, it could improve the reliability because some devices, if device node is failing, the network is able to self-healing itself and to use another node to relay the traffic. I wanted also a network with IP, so the support of IPv4 or IPv6, because it's quite convenient. A lot of library use IP, so it's quite good to have it. And I wanted to have something without a central point of failure. So if one device is failing, I don't want to have all the home automation failing. So with this requirement, I found one SoC and one radio protocol. So I decided to use Thread protocol. So Thread has been designed for the Nest product, and Google has open sourced its own stack, which is named OpenThread. So the stack is open source, and we could use freely. The only thing I think is that we still have to pay a license to sell a product. That's the only limit, I think. For the SoC, I've used one from Texas Instruments, which supports sub-gigahertz and 2.4 frequency, and it supports a lot of protocols. So currently, I want to use Thread, but later, if I want to use other protocols, I could do a firmware with other protocols. The only issue with Thread is that it doesn't provide any application layer. So basically, you have all the communication, you have the meshing, you have some other features, but you don't have anything specific for the home automation. So I had a look to different existing protocol or application layers, and end up with using CoAP. So CoAP is like HTTP protocol, but for constrained device, for device with low CPU capabilities, expected to be low power. I didn't wanted to do my own protocol because it's one protocol again, one more. But for starting, actually, it was simpler. Maybe later I'm planning to switch to Mater, which is a protocol that is intended to be run on top of Thread, and that is intended to be quite standard, and that is more and more supported by devices. But Mater is quite complicated to use as a first time. And I think it comes with a lot of constraints. One constraint was for Thread is having also Bluetooth working, which is not the case with the SoC I've selected. So about the TI SoC, I selected it because it was already supported by Zephyr. The radio was already working, but only 6LoWPAN was enabled. So I had to enable OpenThread support. It was quite easy to do because the driver is well done, and all the network stack in Zephyr is well done. So it was really just a couple of things to add. Only missing was a couple of operations that was not implemented because it was not needed for Sixlopan, so I did it for thread. The main challenge was testing and validating that thread was working correctly, because I don't have access to the Thread Foundation testing tools, so I had to test it myself manually with some command line provided available in Zephyr. So it was quite long, and to be honest, I don't know if everything is supported. I don't know if the device is really thread compliant. So for implementing the application layer, I had two choices for co-app. Basically, Zephyr provides its own co-app library, which provides a lot of helpers, is quite easy to use, fun. But OpenThread also provides its own library, which works a little bit differently. My first intent was to use only OpenThread co-app, but finally I changed my opinion, because I want the firmware to be also able to run using other radio. So my primary target is thread, but I may want to use Wi-Fi or other radio. So finally I will use both. For OpenThread devices, I will use the one provided by OpenThread, and in the other case, I will use libcoapp from Zephyr. CoApp is designed to work as a client and server application. So you have a device that runs a server, and you have some others that must be client. The issue with server is that it consumes more power, because you are listening for events. For that, you have to keep the radio on, so it consumes much more power. So I try to design as much as possible the protocol to run as a client. So the device, when it has a new state, pushes the new state to the server, and most of the devices could run as a client. The only exception maybe is with light or power switch devices, because they are connected to power line, so there is less power consumption issue, and they need to react quickly. Basically, when you push a button, you want the light to switch on quickly. You don't want to wait. So the idea with the full stack would be to have some devices working standalone. Basically, you could have a switch that is powered by a battery, connected directly to a light bulb. So you still have your switch close to your couch, as example, and you could switch on the light, and it must be connected directly. In that way, you are sure that it always works. You could also have the devices connected to a server, and this server will be the link between all your devices and your home automation system. Here in this example, Home Assistant. As example, you may want to have you switch your light using the switch. The light will report its state, so now I'm on, to the co-app server, and then an assistant will use the co-app server to know that the light is not on, and show it in the dashboard. Using that way, I use Home Assistant personally, but we could do that the same for a different home automation system. So in the firmware, we have first the notion of device. So the device itself, I think the device is quite bad name because it's conflict with Zephyr device structure. So, but the idea is you have some place where you describe some information about the device. So the firmware versions, the unique ID of the device, the device type, things like that. And you manage the life cycle of the device. So basically, what to do when the device loses its connection. You could manage the discovery because it's common to the device. You could manage the provisioning. So what to do when your device need to be connected to an existing network. And each device has one or more entity. So the idea of entity is that you define some features and you could have different features for the same device. Basically, you could have the light entity for a light device or a light switch. And you can specialize this entity with the capabilities. A light switch, we just have on-off. A light switch with dimmer feature will have on-off and dimmable. And a light bulb could have dimmable color because it has RGB inside, and so on. Everything is configurable using DTS. So you define the hardware revisions, device name, anything interesting for the home automation system. And inside this row node, you have the child node that defines the entities. And that's where we map the software component with the drivers. We tell to use this GPIO to control the relay. Each component has the same structure. So basically, most of the time, it's a client co-op client, sorry, that will only publish its new state. So if we have a temperature sensor, we will every time the temperature change and the device is wake up because it got an interrupt from the interrupt sensor, we will send data to the server to say, hey, my temperature has changed. Here is the new temperature. In some cases, we may have also a co-op server. So in the case of the light, we have one server. So here we are waiting for command from another device or from the home automation system. So here in the case of light, we are waiting for the state to change to be on or off. Currently, we are using JSON for the data. This is not ideal. Clearly, is not optimized, but for development, it's more easier because with some command line tune, I could easily send some commands to the device and test and validate that it works. Later, I'm planning to switch to, I think it's CBOR, which is like JSON, but in a binary format, more optimized. And the components are trying to use as much as possible the existing API from Zephyr, because Zephyr has a lot of things available, and it doesn't worth to reinvent everything. The only case I had to rewrite an API was for the light, actually, to develop light driver. My first intent was to use LED drivers to control all the LED inside the bulb, but it misses the white temperature control. That's not something that is available in the LED driver, and I don't know if that's something that really deserves to be in the light in the LED driver. I have implemented some simple discovery protocol that use co-op. It uses multicast, so a device could just find by using multicast a server without having to know its IP or things like that. And the server will respond to the device, and they will exchange to the discovery. For the light service, it's quite simple. I implemented most of the basic features, on-off, brightness, white temperature control, color for the device having RGB. So everything uses co-op, as I already said. Something convenient I've developed is services. I use a state machine to manage the different hardware state and the different hardware events. The home automation devices could be very different. We could just have one sensor with one button to do the pairing, and one light bulb that has no button, and we have to deal with it to implement more or less same features for joining a new network. So you may have different hardware events, very different. You could have very different states. So using a state machine, we could define some common state, some generic state. So we could have the state for pairing, and the way to do the pairing and the way to start the pairing will be managed using the state machine and the hardware event. This allows to have everything in a central place, and also for the device having a status LED, to have one place where we could manage this LED. So currently, I've been able to build a power and a light switch. So it's still a prototype at the moment. All the schematics and the PCB are available. I made to bring up a couple of months ago, and still need to address some hardware issue, but there is something already working. I tried to flash my firmware in a real light bulb, and I've been a little bit disappointed because most of the SoC used in light bulb are ESP 8266, which is not supported by Zephyr. Actually, it could be used just for connectivity, but you can flash the firmware inside. So, and the other SoC I found in light bulb were using secure boot, so I was not able to flash it, which is a good point for the vendor that did that, but was not good for me. So next step will be to switch a module to find one module available with secure boot enabled, and just to replace the one with secure boot with mine, and to flash it with my own firmware. I didn't have the time to do it before this conference. So the firmware, the current sources, has already a couple of services available. So the discovery, the light, others are going to be developed. I'm mostly working on it on my spare time, so it takes time. So the next feature I would like to have and to implement quickly is the OTA. Because I want to be able to update the firmware using OTA. Actually, almost everything is already ready. We just miss the protocol itself to deploy the firmware on the device. MCU boot is already working with Zephyr, and it's quite easy to use and to install, to flash a new firmware with MCU boot. So really, we just need to download the new firmware and to use MCU boot and everything provided by Zephyr to flash it and to switch to the new firmware. Another thing to do is provisioning. So how to add the device on the network. So for Wi-Fi, I already done more or less something. It's not finished. But when a device is connected for a device not connected yet on the network, it will start in AP mode, and will wait for the user to connect it using a smartphone and to send the credentials, and then it switches to station mode. So this is already working. We just miss here some applications for a user. I mean, an application on smartphone or something like that. And again, it was super easy to do because Zephyr has everything to do that. So it was just integration and just calling the right functions. For OpenThread, it's a little bit more complicated to do the provisioning. So there is no easy way to do it. Most of the devices doing provisioning use Bluetooth, but so far it doesn't work on my SoC. One big feature I would like to have is a secure boot. I think it's mandatory to have it. I'm sure it's not the case in most of commercial products. So having secure boot is not difficult. It's mostly using tools from the vendor. But what is challenging is having secure boot, but still having a way for makers to flash the firmware themselves without making the device insecure. So far I didn't have found any solution for that. I think at some point I will have to do some trade-off, maybe. Don't know. Another point is the security. Currently everything is sent on the network as a plain text. So it's okay for a light bulb, I think. There is no it's not too risky. For a door lock, it's not okay. So CoAP provides some features for encrypting data. So it supports the DTLS. So that's something I'm planning to enable later. It makes things much more complex as soon you enable security. So maybe again there will be some trade-off on some devices keeping plain text, and maybe on some others such as a door lock having a security enforced. All the sources are available. So there is Pandora, which is the firmware for Zephyr. Pandora hardware, which provides the schematics and the PCB. There is the BOM. I think it's a project made with KiCad. It's quite common for open hardware. And I made a POC for which is named CoAP to MQTT. The goal is to have one bridge that takes that to bridge between the home automation devices using CoAP and MQTT. MQTT is a protocol that is quite popular in home automations, and it's supported by many home automations boxes. So that's something that is used in Home Assistant. So I just made a little POC to try that I was able to control the light from my Home Assistant. Do you have any question? Yes?
So you mentioned you have the CC3052.
Yes.
Which you do, and you also mentioned subconverters, but as far as I know, thread is only defined on 2.4.
Yes.
Someone did that on subconverters, or you just use 2.4?
It just use 2.4. So yes, the question was about the CC3052 that only use that supports sub-gigahertz and 2.4, and yes, thread doesn't support sub-gigahertz. It's not specified, so we are only using 2.4. I made a little POC using sub-gigahertz, but it's just a POC, and until Thread Foundation specify it, it's not a good idea to use sub-gigahertz with Thread. Another question? Yeah.
Did you look into porting your firmware also to normal chips, supporting Bluetooth and also for the radio part? How about image testing and global charger?
Yeah, okay. The question is about this hardware selection. So yeah, I had a look to some Nordic chip. Actually, I use it currently at work. One stupid reason to use this TI SoC initially was because I already used it in the past for another project, and I had some development board already on my basket. So that's just sad. But the way anyway Zephyr is working, it's quite easy to use another SoC, and I'm planning to use some Nordic chip for a little bit later.
Did you look into mesh testing and
I didn't try the meshed. I know that some SoC are supporting thread, and so I would expect that it just work with meshing with FootageShow, but that's not something I tried yet.
To ask about did you use some standalone solution, or it's just a part of other solution?
What do you mean by standalone solution?
I don't know, maybe a library or something. Standard.
Which one?
I mean, is implementation of mesh is a part of standard library implementation?
Oh, for the mesh networking?
Yes.
No, the mesh networking here is implemented by OpenThread.
OpenThread.
Yes.
Okay.
And I think that's the same for Zigbee. It's part of Zigbee. There is no, as I know, there is no real standard for meshing. It's always on top of 802.15.4. Yes?
Okay, so you talk about wireless communication.
Yes.
Whole whole automation. Generally, especially in older buildings, there is a huge problem with wireless networking because usually they build with very thick walls. I had this problem in my own projects, and usually I had to switch to wired networks. Do you consider any support for wired communication using your code and your idea for the project?
Yeah.
In the future, of course.
Yeah. Actually, during the development, I was using Ethernet. So as soon as the wire protocol provides IP, it should just work. Anyway, yeah. Oh yes, I will publish them on the Open Source Summit site. Yeah. Any other question? No? So thank you.